Hello everyone. Today I Shubham Muske will introduce about what is stop words, what is streaming, and what is feature selection technique. So we see our aim. Consider a suitable text dataset. Remove stop words. Apply streaming and feature selection techniques to represent documents as vector. Classify documents and evaluate precision and recall. So we see what is precision and what is recall. So we see what is precision and what is recall. Precision attempts to answer the following means precision is defined as TP divided by TP plus FP. Let's calculate precision for our ML model from the previous section that analyzed tumors. True positive 1, false positive 1, false negative 8, true negative 90. Precision values is given as 1 divided by 1 plus 1 means zero point 0.5. Our model has a precision of zero point 0.5. In other words, then it predicts tumor is malignant. It correct 50% of the time. Then what is recall? Recall attempts the following answer means it has some mathematical formula like TP divided by TP plus FN. Let's calculate recall for our tumor classifier. True positive 1, false positive 1, false negative 8, true negative 90. Recall. Recall has TP divided by TP plus FN means 1 divided by 1 plus 8 equal to 0.11. Our model has a recall of 0.11. In other words, it correctly identifies 11% of all malignant tumors. After precision and recall, we see our objectives. First objective is implementation of the problem statement using Python, and second one is remove stop words, apply streaming and feature selection. In theory part, we see stop words. Firstly, we see what is stop words. So what is stop words? A stop word is a commonly used word that a search engine has been programmed to ignore both when indexing entries for searching and when retrieving them as the result of a search query. We would not want this word to take up space in our database or taking up valuable processing time. For this, we can remove them easily by storing a list word that you consider to stop words. NLTK, Natural Language Toolkit, in Python has a list of stop word stored in 16 different languages. You can find them in NLTK data directory. Then we see sample text with stop words. It has words like gigs for geeks, a computer science portal for geeks, and this sentence without stop word is gigs for geeks, computer science portal geeks. Can listening be exhausting? Is a second sentence, and it containing their without stop words like listening and exhausting. And third one is I like reading so I read without stop word is like reading read. This one consider as without stop words and with their text. Then to check the list of stop word, you can type the following commands in the Python shell. We consider the command like import nltk from nltk.corpus, import stopword and print stopword dot words English, means it remove English word in our sentences which we have given in the given shell. Then in stopwords, in computing, stopwords are which are filtered out before or after processing of natural language data. Though stopwords usually refers to the most common words in a language, there is no single universal list of stopwords used by all natural languages processing tool, and needed not all tools even use such a list. Some tools specifically avoid removing these stopwords to support phrase search. Any group of words can be chosen as the stop word for a given purpose. For some search engines, these are some of the most common short function words, such as the is, at, which, and on. In this case, stop words can cause problem when searching for phrases that include them partially in names such as the, who, the, or take that. Other search engines remove some of the most common words, including lexical words such as want, from, query, in order to improve performance. Let's see our implementation in Python module. It has their NLTK implementation. Then let's see the implementation. Here is the implementation of our stop words. How to remove the stop words we have see here. Firstly, we import NLTK. We have to download our stop words with the NLTK. Then we have to download Punkit with NLTK, and here is the code to remove stop words with NLTK tool. Firstly, we import NLTK with tokenites and send tokenites and word tokenites. Then import stop words. We have considered as data as variable. It contain all words and no play, make, jack, dull boy. It is our sentence, and we have to remove the stop words from this sentence. Stop words set the stop words with English, and words tokenized with data. Then word it can filter with array. We have to given as a for loop with w in words. If w not in stop word, word filter is append. Then word filter is append. Then print the word filters. Then we see our word filters with without stop words. We have see our sentence. Then we see what is stemming. Stemming is the process of reducing inflected words to their word stem, base, or root form, generally a written word form. The stem need not to identical to the morphological root of the word. It is usually sufficient that related word map to the same stem, even if this stem is not in itself a valid root. Algorithms for stemming have been studied in computer science since the 1960s. Many search engines treat words with the same stem as synonyms as a kind of query expansion, a process called conflection. A suffix stripping algorithm is famous for stemming. Then we have to implementation for stemming with the NLTK tool. Let's see the our implementation. Here is our implementation stemming with the NLTK tool. Firstly, we import the porter steamer with the sent tokenize and the word tokenize from NLTK tokenize and NLTK steam, and we have to create our variable ps as a porter steamer, and example words is given as python, pythoner, pythoning, python, and pythonly. For we have given a for loop with wi in example words, and print the ps dot stem, and we see our output like this. Python, 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 and python. We have see our words without any with the steaming by using NLTK tool. Then we see what is suffix stripping algorithm. Suffix stripping algorithm do not rely on a lookup table that consists of inflecting forms and root form relations. Instead, a typical smaller list of rules is stored which provides a path for the algorithm. Given an input word form to find its root form, some example of rules include: if the word ends in ed, remove the ed; if the word ends in ing, remove the ing; if the word ends in ly, remove the ly. Then suffix stripping approaches enjoy the benefit of being much simpler to maintain than brute force algorithm, assuming the maintainer is sufficiently knowledgeable in the challenge of linguistics and morphology and encoding suffix stripping rules. A suffix stripping algorithm are sometimes regarded as crude given the poor performance when dealing with the exceptional relation. The solutions produced by suffix stripping algorithm are limited to those lexical categories which have well-known suffixes, with the few exceptions. This, however, is a problem as not all parts of the speech have such a well-formulated set of rules. Third one is a feature extraction. In machine learning and statistics, feature selection, also known as the variable selection attributes, it selected or variable subset selected is the process of selecting a subset of relevant feature for use in model construction. Uh, then feature selection technique are used for following reasons. It has reason like simplification of models to make them easier to interpret by researcher, shorter training times to avoid curves of dimensionality, and enhance generalization by reducing overfitting. Then feature extraction architecture. It has architecture with the raw text, sentences, tokenized sentences, relations, chuck sentences, post tag sentences. It firstly regret with sentence segmentation, tokenization, part of speech tagging, entity detection, and relation detection. The, this above figure shows the architecture of the simple information extraction system. It begins by processing a document using several of the procedures decused in 3 and 5. First, the raw text of the document is split into the sentences using a sentence segmenter, and each sentence is further subdivided into words using a tokenizer. Next, catch each sentence is tagged with the part of speech tags, which will be prove very helpful in the next step, and name entity detection. In this step, we search for mentions the potentially interesting entities in each sentence. Finally, we use relation detection to search for likely relation between different entities in the text. In the above assignment, we conclude that thus we have studied to remove stop words, apply streaming and feature extraction technique to represent documents as a vector. So we stop here. We have to discuss with stop words and streaming and feature extraction technique. So we stop here. Then thank you for your attention. Thanks for all.